College Algebra Exam. College Algebra Exam 2 Review 3.1 through 3.7. Find the vertex and intercepts to the graph. What is the domain and range? All right. So the first one, if it's in a correct pattern, we can just look at the pattern and come up with the vertex. Okay, so here's kind of the pattern. So if the pattern was something like, let's do a general one, say like it was f of x is equal to ax minus h squared plus k, then the vertex would be, right, h, k. Make sure that's h a little better. Okay, now notice that h is negative here and it's positive there. So the x is going to be, the h right here, the negative h right here is going to be flip the sign when you put it into the x value of the vertex. So whatever manipulates the x within those parentheses is going to have the opposite sign for the vertex. The k is going to be direct though, right? So k just goes directly there, and the h is going to be flipped, right? Okay, so having said that, if I wanted to find first the vertex, okay, what I would do is I would say, oh, that's going to be, instead of a positive one, it's a negative one. And then this, the other one's going to be direct, which means it's just going to be a negative one, right? So that's flipped there, and that's flipped there. Okay, cool. First question answered. Now they say they want the intercepts. Okay, well, this is a little more complicated. Okay, so let's say we want to find the x-intercept. X-intercept. Okay, that means we're going to set y equal to 0. So basically what we're going to have is 0 is equal to x plus 1 squared minus 1, which is 0 is equal to x squared plus 2x plus 1 minus 1. All I did is I multiplied x plus 1 times x plus 1, or x plus 1 squared, and that's what it looks like. And then you would get x squared plus 2x plus 1 minus 1, which just gives me x squared plus 2x. Now, it's a quadratic because it has that second power there, so I am going to set it equals 0. Check, already did it. Now I'm going to factor it. And what can I factor out of an x squared and a 2x? I can factor an x out, which gives me x times x plus 2. Next, we're going to say, well, x equals 0, or x plus 2 is equal to 0. Minus 2, cancel, cancel. X is equal to negative 2. So either x is equal to 0 or x is equal to negative 2. Okay, cool. Now these are we're going to write these as ordered pairs for the intercepts, right? So intercepts are in ordered pairs, they're in points, right? So we know the y value of these are 0 because that's what we plugged in right there, the 0. So we put a 0 in for the second one. And the first one's going to be 0, 0, and the second one's going to be negative 2, 0. Now technically at this point we're done, because whenever we try to find the y-intercept, we're going to plug in at x is equal to 0. Well, if x is equal to 0, y is equal to 0. We actually got the answer right there. But let's say we didn't notice this, and we're just going to try to find the y-intercept the long way. That's fine. So let's say we want to find the y-intercept. So we plug in a 0 for x. So we go back to the original equation, which in this case, so it's h0 is equal to 0 plus 1 squared minus 1, which gives me 0 plus 1 is just 1. So 1 squared minus 1. 1 squared is 1. 1 minus 1 is 0. Which is what I would have predicted, right? Because, again, we already got the ordered pair 0 is 0. So if we plug in an x for 0, we get a y to 0. If we plug in y 0, we get an x of 0. So we already knew that. And this just verified that. We plug in x 0, 0 for x, we get a 0 for y. Bam. So, again, both of these verify that, okay? So technically, you didn't actually have to do the y-intercept with x is equal to 0. You already could have known that because the origin was one of the points. Okay, so we found the x and y intercepts. Okay, now we want to find the domain. Okay, now this is a quadratic. It has the second power. So we know at this point the domain is negative to positive infinity. There's no limitation on the domain, so we wouldn't expect it to do anything. We don't have any kind of, limitation on the domain. Might be something like, limitation on the domain would be something like this, or it might be something like this, where an x is underneath a radical for an even power, right? So square root, fourth root, sixth root, or an x in the denominator. These would have limitations, but in this case, we don't have either of those cases, right? So it's just going to be anything. We can plug anything in the domain. Okay, so now we're moving on to the range. Okay, now, this is a little bit different. We know that it's facing up because it's a positive, right? Because this is positive, we know it's facing up. Let me plot some of these points so we'll graph it and then we'll just verify what it is I'm saying with the graph. Okay, so we know we get the origin for one of the points, right? And I got that right here. And then we have negative 2, 0. So I have another point over here, negative 2, 0. We know the vertex is at negative 1, negative 1, so we have there. So we know it's going to look something like that. And then it's going to shoot up something like, let's see if I can do this right. I'm doing this rough-handed, so it's not pretty, but okay, something like that. Okay. So it should look something like this. Now, this should be enough to be able to get a good grip on what the range, what can we expect from the range. Okay, now it is positive. It had positive, right? So it's up. So it's positive, up, right? Now, so what that means is the vertex, that y value is the min. So that's the min y value. That's the minimum y. Min y value. Okay? So, what that would mean is that negative 1, we're going to include it, negative 1, and since it's going up, it goes up to positive infinity. Now, if the leading coefficient here, now there's an understood or implied 1 there, positive 1. If it had been negative, it would be facing down, and the y value of the vertex would have been the maximum value of the range. Okay? But that in this case, it's positive, it's facing up, so we have a minimum value, and then it goes up to positive infinity. If it is negative, it would have a maximum value and go down to negative infinity. Okay, now that's one way of doing it. Let's see what else they're asking. I think they asked for domain range. Okay, cool. What is the domain and range? Okay, and we did that. Okay, so let's try the next one. The next one's a little bit different. You could actually force this second one, y is equal to x squared minus 2x plus 1. You can force that to be in the format of the first one by using something with completing the square. Or you can use a different formula. Okay, so and a different one would look something like, I guess I'll do it way over here. I'm trying to make sure I have plenty of room to write all the steps. I'm trying to write as many steps as possible. So what you would do is basically say, I want the vertex, and the vertex would be something like negative b over 2a. And then what happens when you find the x value, you would plug it in to the function, and by plugging in that, whatever that negative b over 2a, that would give you your vertex. Okay. So what I mean by that is, in this case, we have and this is the same a, b, c's as you would have in the quadratic, but we're only interested in the a and b. So in this case, we would say a is equal to 1, b is equal to negative 2. Okay. So if I want to plug in negative b over 2a, okay, I would say, well, that's negative 2 over 2 times 1, which is positive 2 over 2, which is 1. Okay, and then what do we do with that? Well, we plug it in. So we would say something like, well, y is equal to 1 squared minus 2 times 1 plus 1. We do the exponent first, so y is equal to 1 squared, which is 1, minus 2 times 1 plus 1. And then we do multiplication. We would say 1 minus 2 times 1 is minus 2 plus 1. You can obviously skip some steps here. I'm trying to not skip steps, but you can skip a few steps. So 1 minus 2 is negative 1. Negative 1 plus 1 is 0. Okay, so what that means is when I plug in a 1, I get a 0. Cool. Okay, so our x value is this, and our y value is 0, and we can write that as an ordered pair of 1, 0. We got our vertex. Excellent. Okay, we got our vertex right there. Okay, that was the first question. Next, we're looking for the x and y intercepts. Okay, x and y intercepts. So that's going to be, let's get some more room on this x and y intercept. So x intercepts means you plug in a 0 for y. Okay, so what we would do is we'd say 0 is equal to x squared minus 2x plus 1. All right, now this is a quadratic. First step is set it equal to 0. Check. After setting equal to 0, next step would be to factor. Okay, well, we can factor this into x minus 1 squared the whole thing. Okay, and that would be 0 is equal to x minus 1. Okay. Now, at that point, I'm going to solve. So I add plus 1 to both sides. That gives me x is equal to positive 1. Okay, so we found our x-intercept. So I want to write it as an ordered pair. So whenever you have an intercept, intercepts are points, right? So since they're points, we want to write them as ordered pairs. Okay, so x is equal to 1, y is equal to 0. Okay, we actually have to do the y-intercept. We don't have the option of quitting now. Where before we had found the origin, which is both an x and a y-intercept. In this case, we didn't find that, so we actually have to do some more work. So now what we're going to do is we are going to plug in 0 for x. So we're saying y is equal to 0 squared minus 2 times 0 plus 1, which means y is equal to 0 goes away, negative 2 times 0 goes away, 1. Okay, so we end up with 0, 1. Okay? So we have, maybe I should label this. So this right here is going to be the y-intercept. Y-intercept where we plug in x is equal to 0. So this is my y-intercept right here. And then over here, of course, this is my x-intercept. I want to make sure it's obvious, right? Right there. Okay. So we got our x and y-intercept. We have our vertex. And now we want the domain and range. Domain has not changed. So domain is still going to be domain of negative infinity to infinity. There's no limitation of the domain, and so we don't have to worry about that. Now range, what's range going to be? Okay, so because this is positive, right? So the same thing as before, this is positive. So it's going to be up. And you see right there, the coefficient is positive, so it's going to be facing up, which means this y value is the minimum, right? So we are going to start with 0, and we are going to go up to positive infinity because there's no reason for it to stop. Okay, cool. All right, so we did answer the questions, but let's graph this and kind of verify what it was, all this information with the vertex, the x, y intercepts, and the domain range. Okay, so first of all, the vertex is, a little bit, the vertex is 1, 0. So we go 1 to the right, and we don't go up or we don't go down. So that's 1 point. Next, we also have an x-intercept at 0 or 1, 0. So 1, 0. Just did that. Okay, cool. And then we have a y-intercept at 0, 1, 0, and 1 is right here. Now this is symmetric, so we know we're also going to have a point right there. And if we go over here, we should have another point over here. Be a little more careful in graphing this. Okay, so hopefully my graph could turn out a little better. Oh, no, didn't turn out any better. Okay, well, that's okay. You can actually plug in more points there. I drew it. I mean, you could go one more point in, to the right, to the left, and put another point in there. That wouldn't be such a bad idea, actually. 2. So it would have been a point there. So I was actually pretty close. Not close enough, but it wasn't super far off, so I'll be happy with that. Okay, so that's what it looks like, and that just verifies what we said. We said the range was 0 to infinity. Notice that I use a bracket on both of these ranges because we are including 0. There's no hole there at the vertex. That point is included in both of these, so we do have to include the y value in that point.